In this video, we are keep going practicing differentiation skills, mastering differentiation. And in this video, we're going through chain rule. Chain rule basically follows the idea of the rational you differentiate of the function outside, and then multiply by the derivative of the function inside, and repeat it as many times as needed, depends how many chain rules you need to apply. Let's start. Y prime is, first of all, I can see a product rule here, so it's going to be U times V. Review product rule from the previous video. Derivative of U is derivative of 3x plus 4 to the 5. Chain rule tells me that I see something raised to the 5, so 5 goes down, multiply by 5, copy the piece inside, because you cannot touch it yet until you finish differentiation of the power of the using power rule. Change the power to 4, decrease by 1. Then chain rule says times, look inside and differentiate the function inside. The function inside is 3x plus 4. The derivative of this function is 3. This is only derivative of the first function. Product rule tells me that now I can copy the second function, 6x plus 7 raised to the 8 plus. Now I'm going to copy the first function, 3x plus 4, 3x plus 4 to the 5 times. It's time to differentiate the second function, and I see that it is something raised to the 8th power. And when I'm saying something, yes, of course I see it's 6x plus 7, but I pretend I don't see it yet. I cannot touch it yet. So first, I know we need to use a power rule, which means 8 goes down, multiply by 8, copy the function inside, 6x plus 7, change the power, the exponent, now it's raised to the 7, times the derivative of the function inside. Function inside is 6x plus 7, so it's going to be times 6. This is basically the answer. What else you can do is to multiply out those constants. So you're going to have 15 over here, and 6 times 8, which is 48 over here. And if you want, I can rewrite everything. It becomes 15 3x plus 4 to the 4 times 6x plus 7 to the 8 plus 8 times 6 is 48 times 3x plus 4 to the 5 times 6x plus 7 to the 7. And this is the answer. Next one is a quotient rule. And when we're going to be doing quotient rule, we will have to use chain rule at the bottom for the function at the bottom, because it's 2 minus x raised to the 5. Y prime is square the denominator, 2 minus x. 5 times 2 is 10. Remember, properties of exponents, since we're raising to a new exponent and it's already raised to 5, 5 times 2 is 10. We have to multiply the exponents. Derivative of the function on the top is 1, because derivative of 2 plus x is 1. Copy the bottom, 2 minus x to the 5 minus, copy the top, 2 plus x. And now the interesting part starts, is chain rule of the denominator. I see something raised to the 5th power, so 5 goes down. It's going to be 2 minus x to the 4 times the function of the derivative of the function inside. What is the function inside? 2 minus x. Derivative of 2 minus x is negative 1. We need to simplify this. It's going to be 2 minus x to the 10th power. The numerator will be 2 minus x to the 5th power, minus times minus becomes plus 5. Let's put 5 at the front. 2 plus x times 2 minus x to the 4. As you can see, we can factor out 2 minus x with the smallest exponent. The smallest exponent will be 4. So let's factor out of that piece. It's going to be 2 minus x to the 4. Factoring out gives us 2 minus x. And the first factor plus 5 times 2 plus x. If you don't mind, I will skip this step and distribute. 5 times 2 is 10 plus 5x. I distributed because I'm factoring out this whole piece, 2 minus x to the 4, so that will give me 1. And I know I can distribute 5 into 2 and x. The bottom stays the same, 2 minus x to the 10. Since we assume x is not 2, the denominator is not 0, I can cancel out 2 minus x to the 4 to the 10 becomes 6. 10 minus 4 is 6. Simplifying the numerator gives me 2 minus x raised to the 6. And what stays at the top is going to be 2 plus 10, 12, minus x plus 5x plus 4x. 12 and plus 4x. In the solution, I can see we factor out 4 for some reason, so it becomes 4 and then 3 plus x. I'm not going to do that. I think it's good enough. Next one. This one seems to be a short version of what we did before. Negative 6 goes down, 2x plus 5 to the negative 7 or negative 5. Negative 6 minus 1 is minus 7 times the derivative of the function inside. The function inside is 2x plus 5. The derivative of 2x plus 5 is 2. If you want to rewrite this as a fraction, it's going to be negative 6 times 2 is negative 12 over 2x plus 5 raised to the 7. Since we had negative exponent, we were able to put 2x plus 5 to the negative 7 into the denominator with a positive exponent. For 16, we have to review or remember again derivatives of trig. I see that there is a sign outside, and inside of the sign there's a secant function. So chain rule tells me first differentiate sign, then times derivative of the function inside, which is derivative of secant. Derivative of sign is cosine. Don't forget, don't change the piece inside, copy it. You cannot reach it yet until you finish differentiating the function outside. Derivative of the function inside is derivative of secant. Secant copies itself times tangent. And this is the answer. 17 looks like either a quotient rule with a chain rule in denominator, or I would even rewrite it, if you want, as 7x to the 4, let me choose another color, 7x to the 4 plus 3, the negative 1/2 power. This way it's actually going to be faster to differentiate, so let's do it this way. But if you want to do quotient rule, you can do quotient rule. So it's going to be, I will do like this, or quotient rule, u over v prime. So let's see what's going to happen if we were doing quotient rule. Negative 1/2 goes down, it's going to be negative 7/2. Copy the function inside, x to the 4 plus 3, negative 1/2 minus 1, it's going to be negative 1 over 2 minus 2 over 2, negative 3 over 2, times, chain rule says now you can look inside and see and differentiate the function inside. The function inside is x to the 4 plus 3. So the derivative of that is 4x cubed. If you want to rewrite that as a fraction again, then how do you know what goes down to the denominator? Whatever has negative exponent goes down. So I'm going to have x to the 4 plus 3 raised to the positive 3/2 in the denominator. Now, negative 7 times 4x cubed goes to the numerator. So it's going to be negative 7 times 4, right? Which is, oh, we can actually simplify, I can see. We can simplify 4 and 2, so that's just 2. 2 times negative 7 is negative 14. But I wanted to explain before that 2 here originally was in the denominator, so it will go to the denominator. But since we simplified, it just disappeared, cancelled out. Don't forget, I missed something. What did I miss? Did you notice? X cubed. X cubed is in the numerator. And that's a good answer. 18. We're actually almost done. Look how fast we go. Hopefully you can do it as fast as I can. And that's the level we hope you to gain at some point. Okay, I see cosine raised to the 8th power and then multiply by 6. So I see something raised to the 8th power. I know how to deal with that. 6 times 8 cosine to the 7, right? You remember that. So we're decreasing the exponent. Again, cosine to the 7x is the same as cosine x, everything to the 7. So if you're confused by this, see it as everything to the 8th. And 8 goes down, change the exponent to 7. But don't stop yet. Now chain rule says, look what's inside and differentiate the function inside. I see inside cosine. Derivative of cosine is negative sine x. The answer will be 6 times 8, 48, negative 48, because of this negative sign. Cosine to the 7x, sine x. Next one is a little bit confusing. Seems we're going to have several chain rules here. You need to figure out which function goes last and start with that one. To do that, I always teach some kind of trick or a hint. Plug some number and see what's the last operation you're going to do with that number. If I plug 1, then the first operation will be 1 raised to the 7. Then I will do cosine of that. And then the answer should be squared. Because basically what's going on here is we have cosine of the polynomial raised to the 2nd power. So now I see that indeed raising to the 2nd power is my last step. So I have to start with this step. When I differentiate, this is my last outside function. So I see something to the 2nd power. That means 2 goes down. Copy everything you see inside. You cannot touch it yet until you're finishing using power rule. X to the 7, change the power, so it becomes 1. I will even keep the brackets for you. 1. Now chain rule says you can look one step inside, only one step inside. One step inside, I see cosine of something. So I will do, let me change the color for you to make it more obvious. First, I will differentiate cosine at this moment. Derivative of cosine is negative sine. Negative sine, keep the function inside as it is. Now chain rule says, look more inside. What do you see now? Now I see x to the 7 inside. And then means I'm differentiating x to the 7. It becomes x to the 6. And this is the answer. Let's simplify a little bit. Simplified version will be 2 times 7 and negative sign makes it negative 14. Now x to the 6, that's the last guy. And now cosine x to the 7. Everything raised to the 1st power, so you don't have to write this down, times sine x to the 7. And this is the answer. If you want to imagine how that it looked as a Russian doll or layers of onion, sometimes the professor teach it this way, then representation will be this way. The outside function was squared. So I had f squared. And I do not know what f yet. When I finish differentiating f squared, which is 2f, I looked one step inside. And I finally find out that inside I had cosine. So f actually was cosine of some kind of u. And I don't know what that u is. That's the whole idea. I cannot look inside yet to see what u is. Fine, I differentiated cosine. Cosine gave me negative sign of that u. And finally I could look inside and see that my u was x to the 7. Derivative of x to the 7 was 7x to the 6. This is how it looks like. This is for the number 19 illustration. Number 19. Almost done. Y prime for number 20 is negative 6 goes down, x cubed plus 4x plus 5, decrease the exponent, becomes negative 7, times, now we can look inside and differentiate this polynomial, 3x squared plus 4. Done. Next one, you can always rewrite it as a fraction again. Since we have negative 7 over here, I will have negative 6, 3x squared plus 4 in denominator, and x squared, x cubed, plus 4x plus 5 to the 7th exponent in the denominator. This one you can do as a quotient rule, number 21. And I don't want to do as a quotient rule. I like doing chain rule more. So I'll rewrite it as 2000 sine of 3x, which is chain rule itself, to the negative 1. And this way it will be faster, you will see. You can check yourself at home and do it as a quotient rule, u over v, square the denominator, and so on. And compare which way was faster, my way or your way. I see that negative 1 is outside as the exponent, so first I will do power rule. Negative 2000 sine of 3x to the negative 2, let me use brackets for you, times, now I'm looking one step inside, derivative of sine is cosine, keep the angle the same, 3x, times, now I'm looking one step inside, which is 3x, derivative of 3x is 3. To simplify everything, I will have 3 times negative 2000 becomes negative 6000, and then I can do cosine 3x all over. Since sine has negative exponent, I will have sine squared to the 3x, but in the denominator. You can leave it this way. But I also see in my solutions, which I'm checking with, that they use the fact that cosine and sine are connected, and they rewrote it as negative 6000. Cosine over sine is cotangent of 3x. But there's still one sine left, right? So I only collected this way. Cosine over sine give me cotangent. Still one sine left because there used to be sine squared. But 1 over sine is cosecant. So it becomes negative 6000 cosecant of 3x times cotangent of 3x. Not sure why do we have to switch to these functions. It's not really necessary. Okay, 3 left. Y prime secant. Secant copies itself, remember? So it becomes secant 3x tangent 3x. And you see I'm keeping angle the same because I cannot touch it yet. Only now I finished differentiating secant, which gave me secant times tangent. And I'm looking inside, and inside I see 3x, so I know it's going to be times 3. To make it faster, I'll put 3 in front. It just looks better this way. Make sense? Times 3 at the end. 23 y prime is sine to the 5. 5 goes down, sine x. Why do we need those parentheses? I just like it, sine x this way, to the 4. Look now, times, chain rule says times, look inside. Inside I see sine, derivative of sine is cosine x. Somehow the last examples are actually the simple ones. I'm not sure why, but doesn't matter. And the last example, y prime is. Now, so before I saw sine to the 5. Now I see sine x to the, so before I saw sine x to the 5. Now I see sine x to the 5. What's the difference? Angle raised to the 5th power versus everything raised to the 5th power. That's not the same thing. Input raised to the 5th power versus output raised to the 5th power. Just make sure you understand this difference. Now sine is the function outside, so I will have cosine of x to the 5 times the function, the derivative of the function inside. X to the 5 gives me 5x to the 4. And that was the last one. Again, just to make a very strong point, sine x, everything to the 5, is sine to the 5x. Versus sine x to the 5 is sine of x times x times x times x times x 5 times. Make sense? That's all for this video. Good job for working hard. Keep practicing and you'll be very good at this.